Hello everyone, in this video I will explain how currently I generate random maps for Terra Mystica, and I will also explain what I will change soon to make the algorithm better. So first of all, the river layout has to be given. River hexes are not randomly assigned, or at least not until now. River hexes are given and the land hexes are colored randomly but in a fair way, and I will show you how. First of all, I explain the order in which hexes are colored. The first hex that is colored is some random hex that is not too close to the edge. By the current rule, it has to be at least 2 hexes away from the edge. So let's assume we start here, then we color this hex, and then we go around this hex in a snail route and continuously color more and more hexes. Obviously, sometimes we will go over river hexes. River hexes are obviously not colored. They are just skipped over. And at some point you will also have to leave the map. Then you just go around the map and respawn on the other side and continue the snail route until you have colored every single hex of the map. This is what the program does. So, but based on what does it assign the colors? I've prepared a scenario for you to explain it. So here you see a scenario where the generation started here and went the snail route. Actually, it's exactly the snail route that I showed you, and it reaches this hex. And then it's the question, what color is this hex given? So in order to assign it, we give each color X a score on that hex. And once each color has a score, we can calculate the total score. So we have score. The total score is then the sum of all the scores. And then the probability of the color X to get this hex will be its score divided by the total score. So you can think of it as the score point is kind of like a share on a stock market in a way. Okay, so what is the score formula? In the current algorithm, I use the following. There is a distance value. The distance value measures the distance of the current hex to the next hex that has the color X. The overshoot is something that represents how overrepresented is X at the moment. So first I show you the distance. The distance is a plain value that should represent the cost to getting to the next hex of color X, measured in ships and spades. And here we use a formula where we assume that 1, 2, or 3 ships is an equivalent cost of 1, 3, or 5 spades. So basically we say that the first ship is a bit cheaper than the others because I assume that at some point in the game you will want to build a ship anyways, and then it's it's some cost so the only cost that you pay is that you have to pay it earlier. So we assume it's kind of cheaper. So here I calculated all the distances. You see that yellow is only 1 river hex away. With 1 ship it could reach it. 1 ship is like 1 spade. So these are the number of spades, kind of. Red is very far away. It's, I think, it's 4 spades and a ship. So it would be 5, but we put 4. Basically, if it's more than 4, we just put 4. 4 is the maximum. Gray also is 1 ship away, which means like 1 spade. Green is directly adjacent, so green is 0. So this means that when a hex is adjacent, it always has distance 0. This is good because then the score is always 0 as well, so there's no chance that there will be two adjacent hexes of the same color. Blue is 1 spade away, so it's 1. Black is 2 ships away, so it's 3. And brown is far away, so we just put the maximum value 4. Actually, the calculations are a bit more complicated still, because we do also care about some of the special faction abilities. So for example, like red giants have, for giants, all the transforming costs exactly 2 spades. Nomads have a sandstorm and other things. So there are a lot of like modificators that actually change these values by a bit. Okay, so let's next come to the overshoot. So for the overshoot, we have to count all the hexes. So how many hexes does each color yet have? It's actually a bit more complicated. I will come to the more complicated part later. So here I have calculated. You count the number of hexes and then calculated minus the average, like the expected number of hexes. So the expected number at the moment would be 27 divided by 7, because right now there is 27 hexes assigned yet. So for 7 colors, in an ideal world, each color would now have 3.86 hexes. This means that yellow, red, gray, and blue have a small overshoot. Black and brown have quite some undershoot, and like green has a big overshoot. So this will affect this factor, but you can see that actually all these values are quite close to 4. It's not swinging that much, and that is intended. So the score should mainly is supposed to mainly depend on the distance, but it is also like we also keep track of total numbers. So there is still one thing that makes this calculation a lot more complicated, because we are actually not weighing each hex equally, because central hexes are more important than hexes at the edges. So I give you here a rough idea what values do hexes have. So we kind of give a 1.5 to the most central hex, and then it will decrease in a square function, and the edges will only have 0.5. So we weigh central hexes about 3 times the value of the edge. So yeah, but so in this calculation we didn't include it now. Yeah, but if we use these values, the following scores would appear. So yeah, it's actually just this formula what we use here everywhere. Then we have these scores. Out of those we calculate the total score, which is 71.32, and this results in the following probabilities. So brown has the highest probability of almost 32%, and yeah, green has no chance, gray and blue are quite unlikely, yellow also unlikely, but it can still happen. So what are the current issues with the algorithm? One I just mentioned. So it can happen that yellow gets this hex. So yellow would be quite lucky. And this can not only happen once, it can happen many times, and then yellow has a fantastic map and other colors have a way worse map. And it can also go the other way. A color can be very unlucky. So this is what I call local unbalance, when a color has clusters where they have a lot of native hexes and cheap digs. They can get very cheap towns. So what can also happen all the time is that in the end not all colors have the same total amount of hexes. So base map and most original maps have exactly 77 land hexes, which means that there is 11 for each color. But in the random generation, it can always happen that a color gets maybe 13 even and another 9, which is not too great. We had discussions that it doesn't matter too much. It doesn't matter too much, but I think it's better to remove it than to keep it, or at least to decrease it. So yeah, total numbers. I also talked about the local unbalance, which is reflected if a color is lucky all the time. Point 3 was a bit more controversial. I do agree on that take that the maps are too hostile, because it does make sense. In the current formula, as I said, the main factor is the distance value, and if we mostly rely on the distance, it means that a hex is usually given to the color that is farthest away, and the one that is farthest away obviously profits the least from a hex. So basically we're just making the map as hostile as we can, and in that regard I think it makes sense that it may be too hostile, and I heard a comment that it happens so often that you need triple digs and it's very frustrating. Some players disagreed, and I will kind of deal with that issue very mildly. So I think the hostility on the maps will decrease a little bit. And the fourth point is quite hard to deal with. So basically, as I said, we're only looking for the next adjacent color. So the distance only looks for one. But it can be that you kind of, for example, invest in 2 ships. So let's say black gets that hex. They are here. And maybe they get this hex as well. This can well happen because the distance to the next is it's relatively far away. But the generator doesn't see at this moment that the investment of 2 ships doesn't only let him go here. It also lets him go here and also here. And who knows, maybe here's another black. So this is quite hard to deal with. But yeah, we use the following solutions. So first of all, we want to try a new score formula that deals with the issues 1, 2, and 3. So first of all, now the new score has 3 different factors. So now the distance value is just 1 out of 3 factors and not 1 out of 2. I think this will decrease its significance, and we will not so much always maximize distances between colors of between hexes of same color. So maybe maybe maps become a bit less hostile. So this is point 3. Okay. Regarding the first point, the varying total numbers, we actually scrapped that over, the overshoot thing, but we just look at the big thing. So we say there is the complete contingent. How many hexes does each color get? So if there's 77 hexes available, each color can have 11. We will have a little bit of tolerance there, so I will probably make it something like 11.1, which means that once a color has 11 hexes, this factor will be 0.1. So compared to any other color that doesn't have 11 hexes yet, the score value will be just a tenth, if at all. But okay, it can, and the distance cannot really equalize that. Then we still use a third factor, and the third factor should deal with point number 2, local unbalance. colors can have a lot of luck. To deal with that, we kind of use some sort of karma. So we already have some luck tracker that tracks the luck of colors. So whenever a color gets a hex, it fills up his luck balance, so it's positive. And if it does not get a hex, it decreases a bit. Unless the hex had no chance to get the hex, then it's neutral. And this way, the luck balance will be positive if a color was lucky till now. Yeah, so basically this value 4, I'm not sure if I will use 4, it could be any other value. The consequence of that is actually just if the luck value becomes 1, this factor will lead to a 25% decrease in the score. Maybe that's good, maybe it should be more, maybe it should be less, I don't know. Okay, and for issue number 4, I can only deal with a test. I will count how many river accessible hexes does each color have. And if there's too much unbalance, I will reject the map and a new one will be created. It will also look at some hexes that will count double. So for example, this hex is very strategical. It's adjacent to 2 rivers, so it's very significant for connection and long distance expansion. So it will count double. And I probably will also count hexes like these double. So I think it will count as 2 rivers if there's river hexes completely on the opposite side. Yeah. So yeah, that's what I want to change, and I hope these changes will make the maps even better and more accepted around the community. So please comment if you have any more suggestions, questions, whatever. Always be welcome, and thank you for watching.